Okay, so in this video we're going to take a look at a simple object model and we're going to see how to use Morphia to persist it. For this example we're going to model what a GitHub object model might look like. So for those of you who've used GitHub, you know you have users and repositories and organizations and the like, and we're going to do a very simplified version of that just to briefly look at some of the features of Morphia. So in this particular file we're looking at the GitHub user, and as you can see at the top there's an @entity annotation, and this is the basic entry point for mapping a Morphia entity. You don't need to use the @entity annotation, but it definitely makes certain things easier for Morphia if you do. So there's a couple of parameters here as you see to this annotation. In this case we're defining the value to users, and what that means is that instead of using the default name of GitHub user for the collection in which to store these documents once we've persisted them, we're instead telling Morphia to use the name users for that collection. By default it will use the class name if you don't pass in this particular parameter, and that's entirely up to you. A lot of people prefer to have plural names for their collection and table names, but whatever works for you is perfectly fine. And this next one is called no class name stored, and we're setting it to true. By default, that value is false, and what that means is that when Morphia converts your Java object to a document to store into MongoDB, it will add a field called class name, which stores the Java class name of the entity that it's storing. You don't necessarily need this. It makes certain types of queries easier if you're storing more than one Java type into a collection. If you have subclasses, for example, in the same collection, you can then limit it so they only get one particular type, but it's not necessary to have, and a lot of people prefer to save the space needed to store that value since it's not needed, and so they use this option to turn it off. We're defining indexes here, but we'll come back to that in a minute. Every Morphia entity needs an @ID defined on it, and this equates to the _ID property in your document, and so the type for this particular property can be anything you want. By default, MongoDB and the Java driver use object ID, and that's what many of the examples will show, but you really can use whatever type works for you. This is especially useful if you're integrating with legacy systems or external systems who may already have a unique identifier in place. You can just reuse whatever it is that comes with that. In this case we're talking about GitHub users, and we already know that their username is unique, so in this particular example we're going to use that particular field as the ID, and as you can see that's a string. And again, this could be almost anything you want it to be. It can be a complex document if you wanted to do that. It can be a long, or you can use object ID if you want as well. So the next field is a full name, and as you can see there is no annotation on this at all. By default Morphia will persist any properties that it finds on your class, and it will store them using the field name of the Java class. So in this case the full name will get stored to Morphia using the name full name as well. If you wanted to change that, however, you can use the @property annotation and pass it the value of the name that you want to use. In this case, we're going to rename the document property member since from the Java world, and we're going to call it since in MongoDB. And this is useful if you have very long field names for whatever reason in Java. You can actually use this to shorten the names in MongoDB so that as you store more and more of these documents, they don't take up quite as much space, because the field names will get duplicated. So a lot of people will use shortened versions of the names in MongoDB to conserve space on disk. But every other property just gets stored unless you have the @transient property in front of it, which we don't see here. And then you can store primitives as well, as you can see, into MongoDB. They don't have to be integers, for example. In this case we're storing ints. Now the interesting thing that we kind of skipped over here is we have this list of repositories. Now a repository is also, as we'll look at in a minute, is also a Morphia entity that we are storing. So in this case we have a list of them, and we're going to tell Morphia that these are references. Now if you've looked in the database you'll see these often as dbrefs in the database, and this tells Morphia whenever it sees the @reference annotation that when it goes to load the GitHub user, it will then go back to load all the repository IDs that it finds in this list. In MongoDB it'll be stored as an array of dbrefs, and then when Morphia loads it, it will then go fetch each of those IDs out of whatever the collection the repository is mapped to, and then hydrate those back into objects. Now we don't always necessarily want to go grab those references when we load, say, a GitHub user, so in this case we're going to pass it the property of lazy with the value of true, which tells Morphia to not load those immediately when GitHub user is loaded. Instead, what will happen is Morphia will proxy this particular getter, in the case of Java, so that the first time you go call get repositories, it will see that it hasn't fetched this list yet, and Morphia will then at that point go fetch those values. You can think of reference, if it helps, like a foreign key, and it serves some of the same purposes, but it's important to remember these are not foreign keys. They are not validated, they're not constrained. You can actually delete whatever document you're referencing here, and MongoDB will neither notice nor care. It doesn't validate that the reference that you're giving it actually exists. So, sort of like foreign keys, but sort of not as well. So, coming back to these indexes, it is often useful to keep all your metadata in one place. And for those who prefer to do it that way, Morphia lets you define your indexes directly on your entities. In this case, we're defining two different indexes, one named popular and one named idle, as you can see. Now, the popular index is a compound index with the properties of username and followers. And this creates an ascending index on username and a descending index on followers. So it'll alphabetize the users with the more popular ones first within a given set of names. This next one is a little bit more complicated still. It's one of my favorite features of Mongo, actually. It's called a TTL index, and it takes a special value of expire after seconds, and then you give it the number of seconds. These indexes can only be defined against date properties, so there's a little bit of a constraint there on where you can use them. But what it means essentially is that after this number of seconds inside your database, there's a thread running that will check to see when this was last updated, this last active. And if it is more than this seconds since this user's been active, Mongo will actually delete this record out of your collection for you. So it's a nice way to expire records automatically without having to manage it. It's probably not the best idea to use it on users, because you'd prefer to mark them as inactive and disable their accounts, for example. But if you're storing logs or any sort of historical records that you quit caring about after a while, you could set this to expire after 3 years or whatever works, and they would just magically vanish from your collection automatically. So there's one more way you can index a field. You can define @indexed directly on a property. In this case, we're not passing a name. These are all the values you can define on @indexed, and most of these are the default values. I list them here mainly for instructional purposes. So the default value is ascending. The default value for the name is blank, which means to create the name of the index based on the field that you're indexing. In this case, the name is optional because we can infer a name from the field. If you're defining an index on the class, you have to give it a name. Or we will use the properties you're using with some munging on the name. So unique is false, drop duplicates is false as well. This is really only terribly useful whenever you're defining a unique index, and what this value says is when it creates the index, if it happens to find a non-unique value in the collection as it's indexing it, just to drop that particular document from the collection so that what remains on this particular property is unique in the collection. And we're kind of scrolling off the side there. So background is false. If you don't specify true here, the index is created in the foreground and it will block until the index is done. If you're creating a new index on a large collection, that can obviously take a while, so you can tell it to run in the background if you want. Sparse is a setting for if created fields aren't on every document, you can define it as sparse, and it has certain properties that help out. And expire after seconds, the default is -1, which means don't create the TTL index as we've just seen. And that is the other way you can index properties directly. There's one more annotation to look at that might be interesting, and then we'll wrap it up, is this version annotation. And what this does is it has to be on a long, on a numeric value. I believe long is the required type, actually. And what this does is every time Morphia saves the organization, it will increment this value as it saves it. And if the old value is not present in the database as it tries to update your document with the new value of this version, it will actually error out saying someone else has changed this document from underneath you and you need to manually deal with those version conflicts. And this is a nice way to make sure that you're not trampling on data that some other process has updated, because if two processes both fetch the same organization out of the database at the same time and then both try to write back, you run the risk of overwriting whatever changes the other process has made. And this is a nice automated way to make sure that that doesn't happen. One more look at the repository. As you can see here, we have 2 references that are not lazy, and these will be fetched automatically every time the repository is loaded. And there are certain performance things to consider when doing that. What we haven't seen on this is if you don't want to store the collection name, there's actually a value that you can set on it that will only store the ID into the collection, and that can also save space because we know which collection this lives in, and a dbref normally stores the collection name and the ID, but we can cheat a little bit and only store the ID there. So that is just a brief tour of how you can map your entities using Morphia. There's a few more annotations that are interesting. There's some lifecycle things you can do before and after you save and the like. The documentation for that is all on the GitHub repository, and I encourage you all to check it out and give it a spin.